case, it will only be this very first resistor right here. I'm going to circle that in blue. That bleeder current is the energy required just to make the rest of the circuit run and function and behave in order for us to allow the 100 volt load, the 50 volt load, and the 20 volt load to run. Typically, we will have a few of the following that we know about this loaded voltage and current divider. I sub B, which is the bleeder current, is usually 10% of total current. So in this case, we are approximately 30 milliamps. That is what we have for our bleeder current. So that blue energy flow that we have here is 30 milliamps. That is our bleeder current. I'm going to redraw this circuit here in just a few moments to give you another perspective as to why that resistor is going to be the bleeder current. Alright, so let's look at that first load. The first load is going to be the 20 volts at 35 milliamps. So electricity is going to flow through my load, through here, and back. So let's just look at green and look at that load. We know that it takes 20 volts. If we know that that load is 20 volts, that means that this bleeder resistor here has to be 20 volts as well. See how it's on the same side, same height as it were? So that means it is going to be 20 volts. So how much voltage is going to be in the middle resistor? Well, that middle resistor has an upper side of 50 volts, and the reason it has 50 is because this is 50. So if the high side is 50 and the bottom side here is 20, that means this power supply at 100 volts needs 30 volts to push through that middle resistor. And finally, if I have 50 on the bottom right here and 100 on the top, that means this power supply needs to have 50 volts of potential to force that current to go through. So the blue loop that you see is the bleeder current. The green loop that you see is through the 20 volt 35 milliamp load. And now if I look at the 50 volt load, I'm going to have a third flow rate that flows through to make that load run, meets up here, and it flows through that top resistor. I have 3 pathways that I can take. And finally, I will have my last flow that leaves through. It doesn't go through any of that series parallel stuff. It is just the last load right here. So that means as I look at the circuit, I will have a total of 4 pathways of current that can flow in the circuit. So let's solve for this. Let's relook at this circuit and solve for some answers here to make your lives a little more easy. I know I've got 20 volts and I've got 30 milliamps. 20 volts at 30 milliamps, if I take 20 divided by 0.03, that resistor has to be a 667 ohm resistor. This middle resistor is going to be equal to 50 volts on the top, 20 on the bottom, so that's 30 volts. But look how much current is flowing. I have 30 milliamps from the bleeder, and I have 35 milliamps coming through that first load. So that means I have a total of 65 milliamps through that middle resistor. 30 volts divided by 65 milliamps will leave me a resistance total of 462 ohms. And finally, the flow through this last guy, I'm going to have a bleeder current of 35 milliamps flowing through him. I'm going to have that green flow of 30 milliamps. So 30 milliamps of the bleeder, 35 milliamps of the load, and finally 40 milliamps through my second load will give me this following equation. I'm going to have 50 volts on the top because I have 100 on the very top, 50 on the bottom, so that means that resistor has 50 volts. I have a total of 30 milliamps for the bleeder plus the 35 milliamps from the first load. That gives me 65 milliamps plus the 40 milliamps from the gray load. That gives me 105. So if I take 50 and divide it by 105 milliamps, that will give me a net resistance of 176 ohms. So 105, and that should give me 105 milliamps. That will give me a resistance here of 476. Alright, so bear with me. I'm going to hit pause, clean it up, and I'll see you in a minute. Okay, so let's look at this circuit now. Bleeder current is going to be the current that flows through this first resistor. It's going to pass through those second two, and we say that that's 30 milliamps. We know that the second load in this particular case is at 20 volts, and he flows through here and he comes through here. So that means coming in at the bottom, I have 35 plus 30, and I'm running out of room, so I'm not going to put milliamps. That means the total current flow in this case, 65 milliamps. That gets me up to this bottom point right here. I have the green, the red still flows. Now I have that 40 milliamps flowing. So I have 65 milliamps plus the 40 milliamps from right there. That means I have 105 milliamps going through that 50 ohm. Let's look at this again on the circuit on the right. The bleeder current. It leaves the power supply. It comes in. Now, the bleeder is this resistor right here. That's that same pathway right here. The green is coming from the power supply, and it comes through here, and it meets up right here. You see how both the 20 volt at 30 milliamps on the left and the 35 milliamps on the right meet up at that point? That means now the green comes through here, and the red come through here. And so now we have that. Those two are merged, and they get to this point right here. And so now the gray is going to flow through, meet up right here. This poor resistor right here has got to feel some of the green, some of the gray, and the bleeder through it. And it feels the brunt of everything. So this poor resistor has got the bleeder, the current from the first one, and the current of the second loads going through it. So it will have to be a higher watt rated resistor. So a loaded voltage divider in the system that you're seeing here is an economical way for designers to take a large voltage and break it down into smaller components to run different items. That's the good thing. The bad thing is if one component goes bad or the value changes beyond what we need it to be, then we're sunk with trying to get something to work that we may not be able to get to work properly. So hopefully this gives you enough understanding as to how a circuit like this will work.